Welcome to the second video of section 6.5, which is solving polynomial equations. First video, we reviewed factoring. This video, we're going to add on to that factoring or build on it using factoring to solve polynomial equations. The steps are at the top. These are steps that you've seen before. When we were solving quadratic equations, we always set the equation equal to 0, factored it if we could, and then use the zero product property or quadratic formula to solve for each factor. That's wordy. It just means set your parts equal to 0. So let's look at example number 1. First thing, is the equation set equal to 0? Yes, that's good. Now we can move on to factoring. So is there a GCF? There is, it's 1. That's not very helpful though. So now we're going to go on to factoring. 3 terms means we're splitting the middle. We are looking for two numbers that multiply to negative 45 and add to 4. That is 9 and negative 5. Now, do I need to go through the whole split the middle process? No, because I have a 1x squared. Anytime it's a 1x squared, you can go right to your factors. So I have x plus 9 and x minus 5 from these numbers over here. Order doesn't matter. So if you have the negative 5 first, that's fine. Okay, so now we have these two quantities. When multiplied, they give us 0. What that means is the first quantity has to be 0, or the second quantity has to be 0. Solving the first equation, I get negative 9. Second equation, I get 5. Now, as a review, how did I know that I was going to get two answers? Look at the degree. So the degree will tell you the number of solutions that you should get. Now remember, some solutions can be repeated. It is possible to have repeat solutions, but we should get 2. Looking at problem 2, again, the degree here, or the highest power, tells us that we're going to have 2 solutions. So let's jump in. First, we need to set this equation equal to 0. Don't start dividing. I know we get tempted to divide by 5 or divide by x. Please don't do that. Instead, set this equal to 0. So I'm going to subtract that 15x. Now I'm ready to factor. First basic step to factoring always is the GCF. So don't forget about the GCF. Looking at my two terms, I can take out a 5 and I can take out an x. When I do, I'm left with x minus 3. Now we're ready to set our factors equal to 0. This one counts still. That GCF you're going to set equal to 0. Dividing by 5 on the first equation, I get x equals 0. Adding 3 on the second equation, I get x equals 3. Again, we should have gotten 2 answers. So when you get to the end, always make sure, did I get the number of solutions I should have? Those two were review. We've seen those before. What I want to do is go on to numbers 3 and 4. These are going to build on the factoring that we reviewed in the first video. Example 3. Again, we are solving by factoring. So sometimes we get tempted to take a cube root. That's not what we should be doing. Move everything to the same side. So I'm going to add 64. So I get y cubed plus 64 equals 0. Now that everything's set equal to 0, I can factor. Starting with GCF. My GCF is 1, so that's not helpful. Now I need to keep going with factoring. I have 2 terms. 2 terms is either going to be a sum or difference of squares or cubes. In this case, we notice that y cubed is y, 64 is 4, 4, 4. Don't forget that you are going to have 2 factors in this case. 2 factors. Sometimes we forget the first one. The first factor, you just bring down the y and the 4. Second factor is when you're going to start your circling. So y times y is y squared. 4 times y is 4y. And 4 times 4 is 16. For our signs, remember SOAP. Same, opposite, always positive. we are not finished yet. We still need to solve. First factor is going to be the easiest one. Just set it equal to 0, and we get y equals -4. So that's solution number 1. Second factor, if we set this equal to 0, we've talked about previously, that's not going to factor more. That is not going to factor more. Let's just double check. Are there two numbers that multiply to 16 and add to -4? No, we should be able to tell that. So in this case, we're going to have to do the quadratic formula. And we can tell our A is 1, our B is -4, and our C is 16. I'm going to review for you the quadratic formula. We get the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. In our case, instead of x, we're solving for y, just because that's what's in the equation. We get the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we get 4 plus or minus the square root of something all over 2. That's something. Please do it in your calculator. So we're going to end up with 16 minus 64, which is -48. Be careful here. We need to simplify that. Don't divide everything by 2. We're not ready for that yet. Have to start with the square root. So I'm going to do that over to the left. I'm going to start by taking out that -1, which is just an I. 48 is 16 times 3. So remember, when simplifying the root, you can either look for pairs or look for perfect squares. I know that 16 is a perfect square, so that's a 4 and a root 3. Of course, don't forget about the I, though. So this is equal to 4 plus or minus 4I root 3 all over 2. Dividing by 2, we get 2 plus or minus 2I root 3. Okay, if we're going to do all that work, let's make sure we check our answers. First, how many solutions did we get? Well, here I have a plus and a minus, so that's 2, and then I have a third answer. Now, did I need 3 answers? Should I have gotten 3 answers? Yes. Highest power is a 3. Highest power is a 3, so I should have gotten 3 answers. So that's good. Now, again, anytime you do a sum or difference of cubes, that second factor will not factor more. You're going to have to do the quadratic formula. Okay, last one that we're going to do together is example 4. Example 4. First thing I want to point out to you is that I have an x to the 4th. X to the 4th tells me that I'm going to find 2, or 4 really, solutions. So x to the 4th, I'm going to find 4 solutions. Step 1, get everything set equal to 0. So I'm going to subtract 3. Now I'm ready to factor. 3 terms is a split the middle. I'm looking for 2 numbers that multiply to -6 and add to 5. Multiply to -6 and add to 5. So let's think. -2 and -3, that's not going to work. That'll multiply to +6. We want -6. So how about 6 and -1? So we have 6 and -1. Now remember that middle term is an x squared, so these should also be x squareds. Now, is it true that 6x squared minus 1x squared gives us 5x squared? Yes. So now we're ready to bring down that first term and bring down that last term. Okay, GCF on the left side, I can take out a 2x squared, and I'm left with x squared plus 3. Right side, I take out a -1, and I'm left with x squared plus 3. My parentheses match, which is good. So I have 2x squared minus 1 and x squared plus 3 equals 0. Okay, set both parts equal to 0. So I'm going to start with x squared plus 3 equals 0, which means x squared equals negative 3. If I take a square root, don't forget plus or minus. Root 3 cannot be simplified, but because it's negative, there will be an I. So we get plus or minus I root 3. We then have 2x squared minus 1 equals 0. So I get x squared equals 1/2. Take a square root. Don't forget plus or minus. Now, this is really the square root of 1 over the square root of 2. Square root of 1 is just 1, and then root 2. Now, how many solutions did I get? 4. I got 2 different solutions, but positive and negative. 2 different solutions, but positive and negative. So I did get my 4 solutions. Now, I think it's important for us to know what these numbers represent. If we were to graph this equation in 4, for example, we know that it has a positive leading coefficient. It's even, so it's going to start and end the same. That's our end behavior. These would be the zeros. Now, the imaginary ones we wouldn't see, but we would see those real ones. So it might go something like this. Sorry, I know that's not beautiful. Where these zeros are 1 over root 2 and negative 1 over root 2. So just so you know, graphically, you're finding the zeros. You're finding the x-intercepts. The imaginary ones, of course, though, we would not graph. Okay, let's move on to the next page, please. Okay, examples 5 and 6 are 2 examples for you to try. So pause the video and try these 2 on your own, please. You may need to look back at the previous examples that we did together to get you started. You also might want to look at the factoring table that we have. Good luck. Okay, example 5. This is already set equal to 0 for us, which is great. So we then should have factored out a GCF. Okay, don't let this one trip you up. What some of you like to do is you say, okay, x to the 4th is x, 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 x. You can't do that. Can't do that. This is a sum or difference of squares. Squares. So x to the 4th is x squared and x squared. 25 is positive 5 and negative 5. So hopefully you got the factoring through there. You then should have finished the problem. I'm not going to go through question 6 with you, but I am going to tell you what you should have gotten. For question 6, your solutions should have ended up being negative 2 and 1 plus or minus I root 3. So if that's what you got, great. If not, please try to find your mistake. Before you turn these notes in, both of these problems need to be completed. Once they're completed and you're ready, turn your notes in. There are some extra examples at the bottom of the page. These are optional, but I'm going to go through them now if you want to. It may be a good idea on these extra examples to try them before I go over them. So maybe you want to pause the video, try these 2, and then watch me go over them. Looking at example 7, 2 terms, so I have to figure out, are these squares or are these cubes? Well, these are squares. M to the 4th is m squared and m squared. 100 is positive 10 and negative 10. Okay, we're going to set both of these equal to 0. First equation, get m squared alone, and then we're ready to take a square root. As always, don't forget the plus or minus. Now, square root of 10 we can't simplify, but because there's a negative, we do get an I. So here are 2 solutions. Next equation, get m squared alone and take your square root. Again, don't forget your plus or minus. How many solutions did we get? We got 4. Don't forget that, plus minus, and that's what we should have gotten. So again, it's always a good strategy to make sure you're getting the number of solutions you should be. Example 8. Set equal to 0 already. That's good. Is there a GCF? 1, which is not very helpful. So now we're ready to factor two numbers that multiply to 12 and add to 7, are 3 and 4. Now in this case, we don't have to split the middle. We have a 1 out in front, so we can do our 3 and our 4. X to the 4th, though, is x squared and x squared. Now, if you want to do split the middle, go for it. That's great. You can definitely do that. I don't want to, though. So set both factors equal to 0. And solve. If I get x squared alone, I get x squared equals -3. Don't forget plus or minus. So this will be plus or minus I root 3. Second one, if I get x squared alone, I get -4. Don't forget plus or minus. Square root of -4 is 2i. Again, check, did we get the right number of solutions? We got 4, we should have gotten 4, which is good. Now, what does it mean if we have 4 imaginary solutions? That one's pretty interesting. If we were to graph this, we know we have a positive lead coefficient, so we're going to end up even function, so we're going to start up also. Now remember that the solutions are the x-intercepts. It's where the graph crosses the x-axis. If we have 4 imaginary solutions, our graph does not cross the x-axis. So it might look something like this. That's just something interesting to know. So thank you for staying on to go through the extra examples with me. Hopefully they were helpful. If you have any questions, please write them down, send me an email, come to office hours, or ask me during class.